Ladies and gentlemen of BlueHat 2025, trust nothing.
Hey everyone.
Hello.
Thank you very much. We're very excited to be here. My name is Ophir Dror.
And I'm Lanyado.
And today we are going to talk about Copilot confessions, or is your GitHub repositories are actually public? So let's start from the beginning. Today we're going to talk about how we started this research and the LinkedIn post that starts this research. We're going to tell you how we found our own repositories exposed out there. We're going to dive deep into Microsoft Copilot. Bar will explain you how it works, and it will explain to you how it allowed us to manipulate it and get secrets from it. We're going to talk about the research process and the results, the disclosure, the mitigation, and we're going to end up with some key takeaways. But before we start, let's tell you who we are. So as I mentioned, my name is Ophir Dror. I'm the co-founder and chief product officer at Lasso Security. I spent the last decade building security products, and in the intersection of AI, product, and basically that's it. I started my career building AI for security teams, and in the last couple of years, I'm building security for AI.
So I'm Lanyado. I'm leading the security research at Lasso Security. I'm an OS contributor for the OS Top 10 for LLM project. And in the past 7 years, I used to research and hack many fields in the security area, from application to mobile, supply chains, and today I put my focus on LLMs. So let's start. Ophir?
All right, let's start from the beginning. In August 2024, we came across a LinkedIn post by Zachary Horton claiming that ChatGPT is actually training on our private GitHub repositories. As a security team, and as an LLM security company, we got fascinated, and we've decided to dive into that and check if that's actually the case. So the first thing we did is we looked the repository in question in GitHub. As you can see, we got the 404 and couldn't get any content. Then we remembered that ChatGPT, at least at the same time, was using Bing as the search engine. So we went to Bing, and we looked up the same repository. This time, we find it indexed. It gave us the understanding that apparently, at some point in the past, this repository has been public. Apparently, it was indexed and ended up in ChatGPT. We tried and probed ChatGPT a bit more and understand if we can actually get the content of this repository, but we failed to do it. And even though we got a bit paranoid, and we've decided to check our own repos. So we asked ChatGPT what can it tell us about Lasso Security repositories. And we were terrified to find our own repository, Lasso LLM, exposed to everyone. Lasso LLM is indeed an internal package that belongs to Lasso. When we did an internal review with the CTO and data science team, we found out that this repository indeed was public at some point in time. We tried and make ChatGPT give us the actual content. This time, we knew what the content should look like. It wasn't an hallucination or anything like that. ChatGPT knew the repository, but didn't give us anything meaningful. All right, so we said ChatGPT is not guilty. We can't get the actual content, and apparently ChatGPT doesn't train on our private repositories. But then we had an aha moment. Bing, GitHub, what do they all have in common? The answer is our gracious host, Microsoft. When we went to Microsoft Copilot and asked the same question, what can you tell us about Lasso Security repositories? We got the answer. We got the actual content from the actual repository. And this time we were sure this repository belonged to us. So we are very happy to introduce our research about the Wayback Copilot. The Wayback Copilot is Microsoft's friendly copilot that gives you answers and data, what we refer to as zombie data. Data that you thought is not available anymore or cannot be accessed, but actually persists inside the copilot. Bar will tell you a bit more about how it works. Before we start, two main points that are important to emphasize. The first one, Data that is exposed online, as I'm sure you all understand, was always accessible, can always be accessible, and there is nothing new here that is specifically relevant to generative AI. But still, the problem with Microsoft Copilot is how easy it is to get exposed and find this data. The second thing, we focused our research on repositories and code. The reason for that is A, because we found a repository and we thought it's cool, but B, because code really does consist intellectual property, secrets, and tokens that can later be used for malicious purposes. We focused the research on repositories and code, but there are still many other areas to investigate that you can take it for later. Bar?
Thank you very much. So, as Ophir mentioned, and as we saw until now in the previous slides, what we know in this point is that from Copilot, we can get context of repositories that are now private and were previously public, while from ChatGPT, we can only get some indications that these repositories exist. We proved it on our own repository. This is how we know this is a real issue and not just hallucinations of the model. And after that, we proved it on few more organizational repositories to see that the issue is still is occurring, not just on us. And we understood we found an issue. Now, the big question is why this is happening. In order to answer this question, we first need to understand how Microsoft Copilot, ChatGPT, and many other LLM chatbots that we are familiar with and working with in our day-to-day job. These LLM chatbots are from a kind of single-step agentic chatbot. It means they are kind of an agent. Agent is a system that equipped with tools like image generation, web browsing, summarization, code execution, or any other tool you want. And what makes an agent is that it will take actions autonomously. It will choose if it needs to generate an image, if the request asked for, and it will understand by itself if it needs to execute code, again, by the input of the user. A single-step agentic chatbot means that it's an agent, again, equipped with tools, totally autonomously, and it will take only one step, only one action, and it will return the response. It will generate an image and will give you the response. It will summarize and give you the response, and that's it. It will not take any further actions after it. Let's see how these tools really works behind the scene. When a user asks a question, the chatbot, like, tell me a joke, the agent knows that it doesn't need a tool to answer this question. It could use the model reasoning. So it will say to itself, I don't need tools for that. It will send the system prompt, its own system prompt, alongside the user query. The model will generate a response. And why did the scarecrow win an award? Because he was outstanding in his field. Wow, they are really bad at jokes, and it looks like we all can know who will be the last to lose their job because of these models. Now, let's take a look about a flow with tools. When a user asks what is the biggest acquisition in the cybersecurity history, the chatbot will say, this time, I need a web browsing tool to get up-to-date data in order to answer this question. So it will send that query to the web browsing tool that will return the best resources and content to answer this question. It will send this content to the LLM with the user query. The model will generate a response. And the biggest acquisition in the cybersecurity history is, of course, Swiss by Google, $32 billion. I think that all of us are familiar with. Now, how the user really knows that the chatbot used web browsing tool? It's pretty simple. Most of the chatbot will return the resources in the bottom part of the response or inline the text, and this is how we can know it. So I think now we understood how the chatbot really works and what is their flow. And now I would like us to take to focus on the web browsing tool. In most of the agents and most of the chatbots, the web browsing tool will be built more of the same. It will contain three main components, which are a query and answer, a search engine, and a temporary RAG, in order to return the best resources and content to answer the question it received. Let's deep dive and see how this really works. So we got it. The chatbot received a question that requires web browsing. So it will send the prompt to the web browsing tool, and the first component it will meet is the query and answer. The query and answer role is to take the prompt and refine it so it will fit to how search engine works. And why we need it? Because of the way we are using LLM chatbots. We are using them with question, instructions, long text, and search engines doesn't know how to work really good with such text. So it will take the user. All of you can try and take your own question you ask chatbots and paste it on Bing or in Google and see the resources you got. Most of the time, it will just not give you the right resources. So the query and answer will take the user prompt, refine it, and pass it to the search engine. Now, search engine will do what it does the best. It will use its own ranker to get the best resources from the search engine DB and return the top results for the query. With these resources, the web browsing tool will build a temporary RAG. RAG is a retrieval augmented generation, which is a well-known technique in the LLM field to use relevant data or up-to-date data without training the models. I will not deep dive too much to how this system really works because it's a whole session. But in generally, what's happened there is that the RAG system will take the query, the user original query, it will embed it, and it will perform a semantic similarity test between the user query and the data it received from the search engine. And this is how the web browsing tool finally returns the most relevant resources to answer a question. Now, as we saw before, the chatbot will take the question, send the resources, send them to the model, and we got an answer. Finally, we know what each component's role in the diagram. We understand what the chatbot's role and what the web browsing tool and the LLM. So now let's see what's really happened when a user asks a question about private repository. In our case, again, Lasso LLM. We send a request. The Copilot says, I need a web browsing tool to answer that. It will pass the query to the web browsing tool. The web browsing tool will return 4 links, which one of them is github.com/lasso-security/lasso-LLM. It will send it. Now, Copilot will send this content to the LLM model in order to answer this question. It will generate a response. And here it is, the structure of our own repository with the files in it and the purpose of each file. But here's the interesting question. Where did the data of this answer come from if when we try to access the link we received is actually doesn't accessible? I think that at this point of the presentation, we can all put our finger on the answer of the source. Let's try to eliminate, okay? Copilot, as I see it, is only an orchestrator, right? It's take the user question, pass it to the right tool, send it to the LLM, take the answer, send it to the user. The data didn't come from here. The LLM model, its role is to generate text. Again, as we saw before, the data didn't come from here. The resources didn't come from the LLM. It just generates response based on them. So it's not the LLM. The only one that stays is the web browsing tool, which in it, we see that the query and answer and the RAG are only engineering processes, so we will get the best results. But the source of the data is probably Bing. And we try to figure what really makes this happens? I mean, again, OK, it's Bing. We saw the pages are indexed in Bing, but they aren't accessible. And then we got to remember, Bing has a feature called Bing's Cache. Now, actually, Bing's Cache indexing most of the internet. It just saves previous indexing, and it's allow you to view it under the cc.bingj.com. What happens here is that when Bing's indexing a public repository and someone is taking it off and changing it to private, Bing doesn't remove it from the cache. And this is why we can all view it by just accessing it or using Copilot. Finally, we understood what is the source of the problem and where the data came from. Additionally to that, we understood two main conclusions and really important ones. The first one is we really got why we didn't succeed to get the content from OpenAI ChatGPT, while from Copilot we did. ChatGPT used Bing, but as an external resource via the API, and Bing did not share this content via the API, while Copilot, yeah, using Bing as an internal resource, its user ranker and the DB as a shared resource with Bing, and it actually has access to all the data and the cached one. The second conclusion that we found interesting here is that this is a really cool issue, and really can get any repository content of that kind using Copilot, but it will be hard to automate that because we need to manually prompt Copilot. Actually, the problem, as we see it, is Bing's cache. So we choose to continue our research and to try to get from Bing's cache as many repositories as we can, and to see what's the data include and what we can do with it. So the first part of this research was to find candidates, find all the repositories that were public and change to private that we can. We looked for mention of such repositories in all over the internet, but actually we couldn't find such one. So what we did find is a data set in Google BigQuery called GitHub Archive that stores logs of actions, actually of any action that happened in any moment on public repositories on GitHub. Again, deleting doesn't here, and changing to private doesn't here also. What we did here, we collected all the public repositories that had an action in 2024 that belongs to organization, and how did we know if they changed to private or not? We just asked GitHub. We sent a GET request to GitHub with all the collected repositories and checked if we received 200 responses. It means that it meant to be public or not. Maybe someone uploaded it mistakenly, but it's not our use case now. And otherwise, it means that someone intentionally removed this repository from being public. The next part of the research was we tried to research how Bing's search page works. And we found that when a page has caching, that has a cache page behind it, there will be a small arrow right next to its links. And when you press it, the cached link will build. And when you press it, you can view all the cached content. So we built a crawler that crawls Bing's search page. And we used a simple Google Doc, site.github.com, the name of the repository between double quotes. And when the search page received all the URLs, we collected all the cached page, all the cached links, and the content in them. Lastly, we tried to analyze what we can find in this data. We searched for secrets, private packages, URLs, interesting code, anything that could be interesting for attackers and could help them in further attacks. So let's take a look at the results. We found over 20,000 affected repositories that belong to more than 16,000 organizations. It means that over 16,000 organizations' intellectual property is actually exposed, while they're thinking they handled the issue and they removed it from being public, and they think that no one can access it. We found over 300 secrets. It included API tokens to almost any cloud provider of some organizations. It contained GCP, Azure, AWS. We found API tokens of OpenAI. We even found a URL for kind of a Kubernetes management service with the secrets right next to it of a really, really big company. Lastly, we found 100 private packages that are vulnerable to dependency confusion, which means we could upload these packages and attack the supply chains of these organizations, and there were more than a few, and we could get initial access to their environment. Cool. Now Ophir will share with you the continue of the research and the story. Ophir.
Thank you very much. So at this point, we were as shocked as you are, and we've decided to do the responsible thing and to disclose our findings both to some of the organizations and to Microsoft. Bar was pretty humble here, but between those organizations, you can find PayPal, IBM, all of the cloud providers, and some other very cool organizations. And we've also disclosed it to MSRC. The response we got in return was that's a low-impact, low-priority issue. The reasoning for that was that apparently this is an acceptable caching behavior. It's important to mention that Google has removed this acceptable caching behavior more than a year ago, exactly for these reasons, because they didn't want unintended information exposure. All right, so we said we did our own thing, and we were happy with our life. But 1 month later, we were shocked to see this message coming from the Microsoft Bing webmaster team. So acceptable or not, on December 2024, Microsoft have decided to remove this caching behavior from their browser. We thought the problem solved. We didn't get the credit, but we're happy that data is safe again. But we've still decided to make another check and to verify the fix. So we went ahead and we checked Bing's cache, and indeed, Bing's cache in this point was inaccessible. We could not see the content of the caching anymore. When we looked for the data on Microsoft Bing, it was still there. It was still indexed, and it was a strange behavior. We were not really sure what was happening. It gave us the idea that maybe this fix is more of a patch. And maybe we as humans cannot access it anymore. Maybe someone else can still access it. And a month later, we had the perfect opportunity to validate our assumption. We came across a TechCrunch article mentioning that Microsoft took legal action against a group that developed tools to abuse their AI service. They didn't only take legal actions, they've also decided to remove all of their repositories from GitHub. And then we had it, a perfect chance to see if we can still access this data. We went ahead to GitHub, we couldn't find and we couldn't access this repository. We went to Bing's cache and to Bing's search, and we couldn't access this repository. And then we've decided to check one last time with our good old friend, the Microsoft Copilot. And there it was. All of the data that Microsoft removed from GitHub was exposed and is still exposed through Microsoft Copilot. It was the perfect chance to show how this mechanism is very vulnerable and very risky. Microsoft's own content, own attackers' content that they try to remove is being exposed through a Microsoft mechanism. Maybe it's low impact, maybe it's an acceptable behavior. This vulnerability still exists today. You can still access a lot of this data using Microsoft Copilot. You cannot access it as a human from the cache. And we wanted to finish with some key takeaways because we think we can learn a lot about how such copilots and how data protection looks like in today's era. So the first thing, which is pretty trivial, is that you should assume that every piece of data that was exposed, even for a brief second, would stay there forever. The problem has always been finding this data again and being exposed to it again. It is becoming much more easy when things are indexed, cached, and end up in someone else's rug. The second point, LLM engines are a new threat vector. What we used to do when we lost information, or we thought we lost information, or when we looked for information, we went to forums, to the open web, to the dark web, and trying to find something that leaked from the organization. LLM engines and copilots are a new threat vector, and you'll be surprised how much of your organizational data can be found over there. Third point, the basics still matter, maybe matters more than ever. Data sanitation, code sanitation, don't keep your secrets exposed in your code, and make sure in general that data or repositories are not public if they don't need to. And the last point that is relevant to almost every LLM system or chatbot or agent, those mechanisms are built on permissions, and they are very, very helpful. So their only goal in life is to satisfy you, and the more permissions they have, the more relevant data that you will get, and this data could be very risky, and it can surprise you how risky it can be. I think this example shows very well what the combination of, by mistake or by design, giving the chatbot access to such information and the chatbot's willingness to help, the consequences of such behavior. We wanted to thank you very much for joining us today. We enjoyed it very much. Thank you.
Thank you very much.